As many can attest, when you join the Globebusters community, you are given a new set of eyes. Now, we've studied Earth science before, but now that we've been given a new set of eyes, it is time to go back and tell you what we see. This is Modern Earth Science Destroyed. Hello and welcome everyone to Globebusters. It's really good to be here today. I'm seeing Liz over there in the chat. Hello, Iron Maiden. And let's see, I've got Cammie right here with us.
And how did I turn sideways? I was not sideways. I was not sideways just a minute ago. That is crazy. That is crazy. Okay. We'll do the back one.
Somehow she went sideways on us. Okay.
It's all right, people. I'm here. You got the back side of it now. I could like flip it around, but then I wouldn't get to see what was going on, and that would be no fun at all. Welcome everybody tonight. It's good to have you here.
Yeah, we've also got Zach in the chat. He's there with us in the chat, so good to see you, Zach.
And hold on one second. Okay,
we're good. Karen's on her way apparently, and we're just kind of hoping she'll show up really soon. But today we're going to be talking about earthquakes. There's a lot of really funny stuff concerning earthquakes that the textbooks just sell out to us and expect us to believe everything they say just because this expert says it. Your textbook says it, therefore it must be true. Okay, Karen's in the chat. She's listening.
She is in the chat. She's listening. She should be joining us any minute. My son did tell me that if I refresh the page, I wouldn't be sideways. But I'm not quite sure how to refresh on an iPad in case anybody has advice on what is the refresh on the iPad. Because I don't have the F keys at the top. I know F5 is refresh. Looking at the chat, looking at it. Anyone?
I wish I could
might have to have
fix
the back view. That's all right. That's okay.
My son
might come in here. Yeah, he might come in here and fix it for me. But it's not worth it. The back, like it's a very, very pretty back view. Very, very pretty back view. And so today you said we're going to be talking about earthquakes and learning about earthquakes.
Yep. So we're going right here to the board where we've got everything we've talked about. On this board, I've got all of our previous things that we've talked about. We've talked, it's been a little while, but some of this is a little bit of a recap on something we talked about a long time ago in the series on earthquakes. But the fun thing about today is what we didn't do in the past with this series was having the college textbooks with us. And now we are able to read the college textbooks and the high school textbook side by side. And it's not just one book. We've got a whole bunch of different books to read from. And I like the bigger perspective on things.
Okay, this is good. This is going to be a lot like last week too, where I heard you start to talk, then you disappeared for most of it, and right at the very end, you clicked back in for me. So we're going to have an interesting dialogue going. We are doing really good on the tech today. Really good. I'm sideways and I'm not hearing.
You're not hearing.
No, you go ahead and present. I can. I mean, I could always go off of the headphones here and listen to on the show there, but I'm watching. I'm looking at the presentations and I'm seeing when you stop talking and I'm catching you a little bit. But I wouldn't, when you're talking and discussing, I wouldn't throw anything at me, taking it for granted that I am hearing it, because it will make it a little bit of a fun, maybe psychic show. That, or you can throw questions out and I can kind of guess at what you might be talking about.
Okay.
All right.
So here in earthquakes, this could be a really short show today. We'll see. There's not a whole ton of points on this chapter, but there's a whole lot of pages that go with it, which is the funny thing. But anyways, I think we all know what an earthquake is. Earthquakes are defined as movements of the ground that are caused by sudden release of energy when rocks along a fault line move. Okay. So this brings up a big thing when it comes to flat earthers in general. A lot of us like to say the earth is firm and immovable, but we acknowledge earthquakes, so we're not quite talking like utterly immovable, right? So earthquakes still happen, landslides still happen. We acknowledge those, but we're talking about like the entire earth itself. It's not a spinning ball in outer space. And I think a lot of this whole earth being a movable thing that comes from the Bible, but even the Bible acknowledges the presence of earthquakes, right? So that's what else would they be talking about when it comes to immovable earth, right? So just wanted to get that out. Do you have any thoughts on that, Cami? You still there, Cami? Okay. So why earthquakes happen? The rocks along both sides of a fault are commonly pressed together tightly. Although the rocks may be under stress, friction prevents them from moving past each other. In this immobile state, a fault is said to be locked. Parts of a fault remain locked until the stress becomes so great that the rocks suddenly slip past each other. This slipping causes the trembling and vibrations of an earthquake. Now, this part gets really interesting. Okay. I think this is talking about aftershocks where they have the initial earthquake and then you wait a little bit and then there's like a second earthquake right after it. And so here they're referring to this as elastic rebound. Earthquakes are a result of elastic rebound. Elastic rebound is a sudden return of elasticity. A sudden return of elastically deformed rock to its undeformed shape. To its undeformed shape. This process is shown right here. So when it comes to elastic rebound, I'm thinking about granite. Like you don't really think about granite, like a granite countertop is having a lot of elasticity to it. Yeah, but it does have some elasticity to it. If it didn't have any of that, then the moment you knock on it, you wouldn't feel any vibrations in the whole thing whatsoever. And probably just one knock might crack the whole thing. Right? That's kind of the opposite of elasticity. So the elastic thing where it's able to maintain its shape without immediately being deformed. That's it. This is kind of the
So
vibration
yeah,
thing.
rigidity would be your opposite of it. So exactly, yeah. And look, I heard you a few minutes.
Okay.
Woohoo!
Is it just you, or do we got people in the chat who's having a hard time?
No, I
Because that
think
always
it's
makes me
just me.
nervous.
That it was making me really crazy last week, but everybody in the chat was hearing you fine. And I've been like trying to do little things. I've got you right now. And when I lose you, I've been like again trying different things with the settings, but I'm not quite sure what it is. It's strange.
Okay. So when it comes to this elastic rebound, what are your thoughts on that when it comes to talking about like on the scale of giant earthquakes? We've got these three little illustrations here of this elastic rebound. Do you have any thoughts on that? Do you think there's enough elasticity in a mountain, for example, to cause a big effect?
I think it's complicated because you have sound along with it, and I've seen sound have a crazy effect on solids, where it seems to again you'll see even like car doors seem to bend and things like that. So I do think that things that are solid, you'll get a little bit of things that seem rigid. Again, under certain circumstances, can become like again. When you think of quicksand or things like that, or hitting a hard surface, versus pushing it slowly. So I'm not sure if I caught enough of it to know where you were going with this, but do you think it's elastic, Kyle?
Not at this scale. Like I can feel like some slight vibrations in the countertop, but if that
Mm-hmm.
countertop like you bend it, it's gonna snap. And
It
so
will,
we're
yes.
talking about like I don't know. I've experienced an earthquake out in California, and it felt like a giant worm crawled under the house, and I can't quite figure out exactly how all of that took place in my mind, because I'm thinking about the elasticity of the foundation of the house I was in at the time, right? And how did that whole thing not break? And it's wild. Have you had any earthquake experiences?
No, I really haven't. I've only been in like very, very tiny ones where I mean, the closest I've had to feeling it is where you think you're in an earthquake because like the water in the hot tub is moving a little bit and you look it up and it's like, oh my goodness, yes, there was a 1.7 earthquake and just enough to jiggle water, but I've never felt an earthquake per se.
Yeah, it's weird. Like you hear, it sounds like gravel just kind of rumbling outside or something like that. Just a whole ton of this loud rumbling, and I really swear that the movie Tremors was based off of just someone experiencing earthquakes. Have you ever seen
So I
that
know
movie?
Karen's backstage
Okay, perfect. Let's pull her in.
and you're cutting off on me again. I don't know why. It's the craziest thing.
Karen, there you are.
Hey, howdy.
Hey, good to hear from you. Sorry, I just totally forgot to introduce everyone.
That's
Now you're
okay.
here, we can do our introductions. So, Karen, I noticed you on your channel, you did a big response to the final debate thing. I thought that was
Oh
great.
yeah. Yeah. Yeah.
Yeah,
Thank you.
I just think it's hilarious on how uh, they made the big deal about the final debate, and if that truly was, sorry, the final experiment. Okay, if it truly
Right.
was the final experiment, there would be no debate, and so
Right?
they acknowledge that. Yeah, they acknowledge that it wasn't it, and so now he's gonna do this, and yeah, obviously there's gonna be a lot of debates to come after this. So yeah, just kind of the audacity of it all, of him saying, "Oh yeah, this is the final one," but it's not going to be.
Yeah. Yeah. Well, actually my suspicion, and I don't know this, but my suspicion is he wants to do that on his channel so that he can make it part of his documentary, you know. And if and I haven't signed any contracts, so if I go over there, I'm just giving him a bunch of video, that he could do whatever he wants with, and I could be portrayed however he wants to portray me. No, thank you.
Yeah,
No,
yeah,
thank you.
yeah,
I don't need to be part of that. I don't want it. I'm good.
yeah. It's also really fun popping in on Coffee Talk with you there. That was good. So hopefully it wasn't too cheesy.
No, it's cool.
Okay. Uh, so anything else happened in your week so far that you wanted to talk about?
Not really. It's been raining a lot.
Oh yeah.
Um, yeah. There's things I wanted to do, but it's just been so rainy outside.
Uh,
It's supposed to be nice this weekend. Anyway, I didn't really mean to interrupt the.
oh no, you're absolutely fine. I promise. Yeah, just out here in the desert, rain is always a blessing. So I
Yeah.
never complain about the rain.
Oh, we get tons of rain out here,
Yeah.
which I'm okay with. But sometimes you're like, all
Okay, boys and
right.
girls, you just popped in for a second and I couldn't get you on any of this stuff talking. I heard a little bit about the final experiment. I am leaving you and leaving and coming back, seeing if I can hear what you're saying, because it would be helpful to respond if
Yeah.
I could hear. Again, this is truly remarkable. So you all have a great show. I'll be back in just a minute. We hope.
Okay. Okay. So Karen, we were talking about elastic rebound, and
Mm-hmm.
we've experienced aftershocks, and here we're talking about some like elastic rebound when it comes to uh, earthquakes in general here. And
Mm-hmm.
it sounds like there's a lot of rebound kind of coming here, but I don't know why this. Okay, exactly all these pictures trying to get the story out of it, because when I think of elasticity, I think about an object has one shape, it gets bent, and then all of a sudden it bounces back into its original position, right?
Mm-hmm.
But I'm looking at these three pictures, and that's doesn't appear to be what I'm seeing. I would have put this picture right here, and then yeah, kind of, why does it look out of order to me?
Well, the difference isn't very much, but it's showing like the piece closest to you with like as if it's like built up a little bit,
Mhm.
right? And then it's almost like the pressure makes them slip, right? It's like it built up, and then
Yeah.
the friction, I guess, is what they're saying.
Yeah.
I've felt many earthquakes because I grew up in the Bay Area
Oh yeah,
of
you're from
California.
California. That's right.
And
So
I was there for that big earthquake in 1989. I felt that one, and numerous others. Plus, living in San Diego, they have a lot of little earthquakes.
so when it comes to elastic rebound, it's kind of hard for me because when I think of like a granite countertop experiencing like a large amount of bending, it does hold. It's gonna crack the countertop. It's not really uh it doesn't have a ton of elasticity to it. Like it has enough that when you knock on it, you can feel vibrations throughout the entire countertop, but I
Hmm.
wouldn't say it's got enough for this kind of bending. You're not going to bend it down to like a 90-degree angle and expect it to bounce
Well,
back into position.
if you look into like stone and rocks and stuff like that, you'll hear people talk about how sometimes when the rock is still deep in the ground, it's actually more pliable than it is when it comes out and it dries out. Does that
Interesting.
make sense? Sometimes the rock being deep underground is actually, it is a little bit more bendy than it would be on the surface.
Yeah, it's a weird thing to think about, bendy and bouncy granite.
Yeah, it
But
is.
this is a good conversation to have with gemologists, right?
Yeah.
So,
Would like for our gemologist to come back.
yeah. We need you. We need you, Cammy. Wish there's more I could do for for her on my end. So this part gets really interesting to me. This is talking about the anatomy of an earthquake, the location within Earth along the fault at which the first motion of an earthquake occurs is called the focus. The point on Earth's surface directly above the focus is called the epicenter. So here we've got this huge fault line, and they're generalizing the focus of this fault line as being kind of the center of that fault line. And then going way up to the top, that's the epicenter, which is on the surface, which isn't really the start of it. And it's a really weird concept for me because I think about where did it go?
Oh,
Rubbing two.
Kimmy's backstage.
Okay.
She can hear.
Okay. Let me pull her back in stage. Yay,
Yeah,
Cammy!
I
The
was
camera's
actually
fixed.
listening good and hearing backstage the whole time about how you could use a gemologist and the whole difference. It's like, oh, I'm here, and I can actually hear, and my camera's fine, and everything seems fine. We'll see how it goes for a minute.
Okay.
And
Perfect. Yeah. Talking about this elasticity, it makes sense that something would be a lot more pliable when it's moist compared to being totally dried out. I just think about clay and about how dried out clay, it cracks a lot more than
Hmm.
really moist clay. So that makes sense. But when it comes to granite, that doesn't quite make sense to me.
it
But
doesn't. We were talking about before I cut out to you. We're talking. You're talking about this. Karen was joining the sound of the earthquakes and they making and how it made such a big sound. And I said that I'd never been in an earthquake, which I haven't. But I had a girlfriend from California that had been in several. And I had in my office for a while as a clever thing. We had those. Do you remember at the bank when you would go to the bank teller and they would send us stuff in one of those little pneumatic tubes to your car and
yeah,
you'd get, yeah. So y'all know what that is? Well, we had extra trade money or whatever going in a company that did those. So we ran because we had so many things going back and forth of high value to my office. I had a pneumatic tube stuff running to my office. Except for what would happen is right before it would come in, if you weren't sending it, it would make a rattling and a shaking. And I was in here working with this girl one day and it started doing that rattling and shaking and she crawled under my desk. She literally crawled under my desk and did this because she'd been in an earthquake the week before. And she was like, no, I just thought that was going to be, it was the tube going over my head. But she thought we were in an earthquake with that vibration and that desk. And so it was, I don't know, we joked about it. We did the camera scenes of her unladylike jumping under the desk and that, but it was pretty funny. I do think some of the things with the sound, and you talk about your stones have brittleness to them and you're going to brittle, but you have with the sound, you have like, again, what I would call your liquefaction in that with the sound and vibration, the things that don't normally bend can with sound, I think, take on properties that are not normally of their, again, I would call like, again, sound a coefficient that it's going to change some of the properties of it.
I'm thinking a lot about the crystals that we talked about a while ago that were used in radios, and we got into that, and that was just really fascinating to me. Just all of the fine details of that. Like, how did they figure this stuff out to cut the crystal in just this tiny little sliver, and then it's going to vibrate in a way that's going to resonate with another crystal really far away? How would you ever guess to even think that?
It's brilliant. It's absolutely brilliant. And again, the more you look into it, the more brilliance you see in it. And then you sit there and look at the reverse side about properties of rocks being all woo-woo and mystical. And again, how they try to say, don't look here, don't look at the, don't look here at all. It's all, it's silly, it's new age, it's crazy, but that's where we get our intelligence from.
Kind of just making those observations around us, right? When it comes to earthquakes, I'm also thinking about how just a large van or truck can go rumbling on by and you can feel it in the ground. Like, the ground has a lot of vibrations that go through it anytime. If you've ridden a horse, I don't know, you've heard of this, the whole hold your ear to the ground kind of a thing. That kind of we think of that too.
Yeah.
So kind of ripples end up going really vast distances sometimes.
Yeah, because sound travels better. Yeah. Sound travels better through denser mediums.
And that one is a really wild one for me to wrap my mind around. Heard about with train tracks and about how the vibrations can travel. I think it was faster through solid metal than they can through air. And yeah, like what? I just can't seem to.
Like the whales in the ocean, like the whales do songs in the ocean, hearing them for so far away, you know, that's why too.
Yeah. Yeah. When it comes to the disturbance of a medium, because I'm thinking about like the density of like iron and about how you've got more that's going to absorb that energy, and you've got a lot more material that's got to be moved. But for some reason, moving this solid material is easier than moving the atmosphere. You see how that would just break my brain? Yeah. Okay. So there's a lot to vibrations to kind of take into consideration. And we're getting to this point on epicenters and how the focus is just kind of the center point along this fault line, and exactly how they determine the length of a fault line. I don't know how they come about in determining this is the exact center of it, without knowing like the edges. Where does the fault line begin and where does it end? But somehow they can determine the center of it. That's kind of, I think, holding up a string. I can't really point to the center of a string unless I've got a beginning and an end. You know what I'm saying? Yeah. So we've got that going on, and I think about grinding two different cinder blocks together. Okay. If you grind two different cinder blocks together, you're going to have the center of that be your focus, and then the top of that be your epicenter. And this ends up being something that we hear all the time. This earthquake took place at this place, and that's about where the focus was. And exactly why they're saying that, I don't fully understand that. But when it comes to all of this, I think about this earthquake, see all of the friction between the rough surfaces between these two cinder blocks. It's going to be like everywhere. I don't see why it would be a pinpoint focus kind of a thing like that. You know what I mean? Especially if there's nothing as smooth as these cinder blocks are.
That's interesting. You call it a focus. I've looked at earthquakes a lot through my life. I mean, I've never noticed it being called a focus, but you are right that they always add the depth. They say what depth it's at. So that would be your focus, would be your depth. And you're saying, how would you know? Or again, when they're picking up a lot of this stuff by buoy motion and that, how do they know the depths of these things?
Yeah,
it's a good question.
A lot of this
I
is
don't know.
guesswork. A lot of this is guesswork. There's a lot of just estimating. We think it was about here, and yeah, I think there's a part on here about determining where it took place. Here's the college textbook on measuring an earthquake size. Okay, the point of
They're going to get
energy
your
released
focus.
the point of energy release for an earthquake, that is the location where the movement along the fault line began, is the earthquake focus, which is typically at some depth beneath the surface. The earthquake epicenter is the location of the Earth's surface directly above the focus. And so they're saying this is that little tiny point is the place that the earthquake began. Okay, the focus. And so I'm going back to the if you were to grind two cinder blocks next to each other, right? And are you going to say that when these started sliding against each other, is that where it began? Can you see this? Kind of like, I think that's like wild and stupid. I don't think anything's causing that to happen unless they're actually like setting off a bomb or something like that. And then that bomb triggers an outward ripple that's going to vibrate through the earth.
Well,
I could say that would be a pinpoint focus.
Well, I guess it would have to have some sort of starting point, because it would have to have a weak point. If there's pressure building up, then the weakest point would probably give first.
Okay. So,
because it's not like, see, those two things are like already cut in half,
yeah,
and you're just grinding them together.
Yeah. But
this isn't really like that. It's like as if they're attached, and then they crack and they shift.
Okay. So if I were to grind these two together, I'm going to be seeing energy all along this entire fault line. It's not going to be just in one location. But every little bump that rubs against the other little bump on the other side, that's going to be a trigger point, right? That's going to be releasing energy. But here it's saying that the place that this whole thing starts is right here at the focus. And so I think what you're talking about when it comes to what started it, maybe like a internal cave collapse, or a cave collapses, and that would be a pinpoint location, right?
But to me, it would make sense, like a lot of different ways. If you had a volcano that causes an earthquake, that would be a certain amount underground that you could measure. A lot of the times you do have the ridges and the pieces that are moving against this, and you do have, again, they're not perfectly smooth little rocks doing sand. You have big places of outcroppings and things, again, where they're tied together just a little bit and they're hanging on by, like, again, your proverbial thread. And something like breaks loose, jars a little bit and shimmies it. So I would think that you could, like, on where the energy is going, pinpoint like somewhat of a depth on it. Are you saying you don't think it makes sense to get to a depth of it, or that because they're like drawing it as a complete absolute point?
I say that the entire earthquake, the entire shift between all of that is happening in one spot when there's energy being released in all over the place. That I think just seems ludicrous to me. I kind of look at this jelly roll, and here you have just kind of focus on the center of the jelly roll and just think about activity happening all along that center, and yet they're saying that it's just in one point. It's right there. When
But don't
they're essentially saying there's only cream at one point in the jelly roll when you can clearly see that there's cream like all the way through it. You follow that?
Okay, I could follow that. Like somewhat, but again, they do have like different types of earthquakes that have different, like again, different. That's why some do big tsunamis, some don't, and the different things on the way they slide. They say against, going against the different angles and things going. So I would think that would accommodate for, because again, they don't put out waves the same. I mean, it's not the same. Each one has got its own personality.
Yeah, I like that. Every earthquake has its own personality. Some of them you do feel like the one I experienced where it felt like a giant worm went under the house. The whole house went up and then it came back down. I was like, what was that? For me, it was really fun. And I was like, wow, this is like a roller coaster. This is cool. I gotta say I went through an earthquake and it was totally fine. So it wasn't scary for me. It was just really fun. But I step outside and everyone down the street, it's the big one. And they're all freaked out. I was like, oh dear.
Yeah, I think it's very, I think again, each one is its own. So some of them, I don't know if you can describe, some of them I think would be really easy to locate, and some of them would be, you're right, they're putting an epicenter on it because they have to on a map, but you're right, a lot of it could be along a zone and striking in multiple places.
Well, that's where the
still wanna see
aftershocks come in too. The aftershocks will be other places on the fault line.
Exactly, triggering it. Again, the other one's hitting it. So yeah.
Yeah. So I can think about like different bending and snapping places. So here they're talking, we're going to get to this in a second. They're talking about different kinds of waves that travel through ground. I've never heard of a love wave before. I think that was kind of a weird one. But P waves, just more side to side. A lot of these ones are kind of, we talked about focus before, and now those being deep underground, and yet all of this stuff looks like it's going along the surface. It's only affecting the surface on a horizontal way instead of like coming up from the underneath you, which is weird.
Yeah.
Okay. So, although the focus depths of earthquakes vary, about 90% of continental earthquakes have shallow foci. Earthquakes that have shallow foci take place within 70 kilometers of Earth's surface. Earthquakes that have an intermediate foci take place at depths between 70 kilometers and 300 kilometers. Earthquakes that have deep foci take place at depths between 300 kilometers and 650 kilometers. I promise you this book is in English. It's not from England though. So yeah, it's weird. It's just they're writing it in.
They always measure that stuff in kilometers.
Yeah. Earthquakes that have deep foci usually occur in subduction zones and occur further from the surface location of the plate boundary than shallower earthquakes do. Okay, it hasn't quite defined subduction zones anywhere that I'm seeing here. By the time vibrations from an earthquake that has intermediate or deep focus reach the surface, much of their energy has dissipated. For this reason, the earthquakes that cause the most damage usually have shallow foci. So it just said the most damage, right, are normally the ones that are along the surface. Okay. So over here, when we jump over to the different kinds of waves, okay, we've got our P waves, pressure waves, and I believe S wave stands for shear wave, which is kind of the side-to-side wiggling. And I don't know about these other ones, but the only ones that really get a lot of attention are the P waves and the S waves. And a lot of that comes down to this section over here about shadow zones. And so here they're talking about that pinpoint location because I can't make it enough of an emphasis on this whole pinpoint thing, because we're talking about like an entire fault line, right? This whole thing is moving. You're talking about like continental drift, kind of giant fault lines, and yet this entire tectonic plate is moving by this one tiny pressure point. That's the whole thing that they're claiming. I'm like, I don't think that one tiny pressure point would be causing this entire city to be moving like a significant amount when it comes to them talking about continental drift. And there's another chapter, we'll probably talk about that in the future. Okay, so shadow zones is the big claim for the Earth is a globe. We know the Earth is a globe because of shadow zones, where we have our epicenter and all these different waves come through, but only one wave can pass through water and the other one can't. I believe it's talking about the P waves just get refracted, and then the S waves, I'm trying to find the spot where it said one of these goes through water and the other one doesn't. I don't remember which one off the top of my head. I'm sorry. Okay. Seismic waves in the Earth's interior. Seismic waves are useful to scientists who are exploring Earth's interior. The composition of the material through which P waves and S waves travel affects the speed and direction of the waves. For example, P waves travel fastest through materials that are very rigid and are not easily compressed. So that's what we're talking about with the railroad tracks. By studying the speed and direction of the seismic waves, scientists can learn more about makeup of and structure of the Earth's interior. Okay. This is an interesting moment where they actually mention a scientist's name, which I have to applaud him because they don't do that very often in this book. Actually naming scientists' names. In 1909, Andrija Mohorovic, a Croatian scientist, discovered that the speed of seismic waves increases abruptly at about 30 kilometers depth because the surface of beneath the surface of continents. The location at which the speed of the waves increases marks the boundary between the crust and the mantle. Okay, just kind of getting into this stuff about mantle, core, lithosphere, all these different layers that we can't really observe that they're there. The borehole is only so deep, but it's like hardly anything on a globe yet. They're claiming to know everything based off of these P waves and S waves. And the existence of these shadow zones. Do you have any thoughts on that so far? I feel like I'm doing a lot of the talking here.
Well, my thoughts on it when they do these things like this is that we have earthquakes and we can measure data, and their job is strictly to take that data and make it fit into the globe model and try to make it match that point. I mean, that's their confirmation bias or their entire way of doing things. So it's not a proof of a globe when they're trying to, they don't know actually what's going on here, and they're trying to take fringe patterns and that and say, how can it make it work on a globe? But that's not again, on there, I don't think I've seen some of the measurements that they did when looking back at this, when we did this 7 or 8 years ago. When you could get to them, they draw these neat little pictures, but when you actually get to the individual earthquakes, they don't work out so cut and dried on the chart. Again, each one has got their own personality, and they're trying to make it fit into and learn about the globe via that, because in their mind, they know that they have an earthquake and they know it's a globe, and they're trying to understand more. So they're using that to extrapolate information. And so for them to extrapolate information or to make up information on there, they're making it up based up on, again, it goes into this backwards logical argument on it, where I remember them trying to use it as a proof, and it's like, and you can't take it down to any isolate on a earthquake either. You guys can model it and say, this is how, and this is why we think the earth is this material and different things like that. But I don't see this as a proof.
Yeah. If I were to be writing this book, I would present how we came to know this in the first place. We've got the name of one scientist here, but we don't really see any of his actual test results. We don't really see what he did. He just observed that waves vary depending on the medium. In some mediums, the wave travel faster, and in other ones it travel slower. And that's really all that it's talking about. It's not really attributing this whole claim directly to him. So where did this claim come from? This textbook doesn't really say it. I'm kind of looking over here now at the giant plate tectonics and how it's not really a smooth surface. And so just kind of one little tiny earthquake there is going to cause the entire thing to move. That's essentially what they're saying. And I don't know, when it comes to earthquakes, it's just silliness. But anyways, back to shadow zones. I found the spot that talked about liquid. S waves do not reach the S wave shadow zone because they cannot pass through the liquid outer core. Okay. So S waves can't travel through the liquid outer core. That's their big claim. Okay. It's a really big deal because we have to look at something called the water table. And so the water table is this ultra saturated zone of water that goes all underneath pretty much all the land. You can see this even going underneath the mountains. Okay. This huge ultra saturated zone. You're going everywhere. But they're claiming that S waves can't travel through liquid. So therefore, this water table, the zone of saturation, they shouldn't be able to pass through that. You follow?
Yeah.
So how does that work? I like there's a section in the textbook. If you jump over to chapter 16, it shows it even bigger. Okay. This giant area of the water table. That's where you get your well water from. You just dig deep enough and it's going to start filling with water is essentially the case. Sometimes when there's more rain downfall, it can actually swell. It actually doesn't stay in one place. It actually rises and falls. That's one thing that the book kind of talks about.
It could be though that there's minerals in there that keep the water from being completely liquid. Like there's certain minerals that absorb water. They work like a storing water deep underground. It's called ringwoodite. I'm not saying that's what it is, but there are. I mean, what is down there? I don't know. How deep is that? How do they know?
That looks pretty deep to me, but I don't think it's quite as deep as like the super deep borehole. Yeah, so this is just talking about the subsurface water zones and the water table. It talks about that's where groundwater comes from, a lot of it. And
that super deep borehole, again, is just 8 miles deep. Again, to put things in perspective, a little bit crazy.
Yeah. 8 miles deep.
I like in the chat, we have the question, could they even have earthquakes on a globe? Or should there be earthquakes on a globe? I don't think so. I mean, because you've got a padded water ball floating in the vacuum of space, cushioned on a molten core and padded by water and all of these different things. I don't really think that in that model we should have earthquakes at all, to be perfectly truthful. Maybe water sloshes, maybe tsunamis, but I don't think we should have earthquakes.
Yeah. I think it's really wild how the water table is a lot bigger than people realize. And how they've got entire underground lakes, okay, full-on lakes of like within caves. I think I just recently saw in the news something about this giant shark that they were able to find fossils of in Kentucky, in one of their caves. Like a 20-foot shark that
would be
was
fun
kind
to
of a
look into.
wild thing. Yeah, I wish I could remember the source on that one. That was a interesting one. These things just kind of fall into my lap, and I let's go. Oh, that's interesting. That it keeps scrolling. I'm like, oh man, that would have been a good one to save on for this one. But yeah, those are I think those are the major 3 things I wanted to talk to you guys about. Was this kind of weird elasticity of mountains, and this epicenter thing where we've got these entire tectonic plates that they're describing rubbing against each other, and it's all coming from one spot. I've never heard of any earthquake that they've ever mentioned that doesn't have some kind of epicenter where they're claiming this was the source of it. I can imagine, like, when it comes to like volcanoes, like a large bubble kind of coming up, and that might cause continental drift. We'll have to talk about that one in another thing where
This one isn't the epicenter.
Tides. Huh?
Aren't they doing the epicenter? When they're doing the epicenter and putting it on there, they have sensors and things going all the way around, and they're just taking data from the sensors and they're pretty much triangulating it.
Yeah, that's what they try to do.
So that's what, yeah. So I think, again, it's just more or less, and even though the earthquakes feel big in area, even like, again, when you're talking about the whole subduction zone or the whole earthquake faults, when you feel an earthquake along the fault, you don't feel it along, again, you're not feeling the earthquake in San Francisco, you're not feeling it in San Diego, you're not feeling it in, they're still quite localized. And they do radiate with the circle, pretty much when you do the did you feel it maps. They radiate pretty darn circular on there. I don't know. I used to look at those all the time and try to report on them, even on those 1.7 ones. There is a app, earthquakes, under earthquakes.us, just whatever you have, or you have an app that if there's an earthquake, you can report if you felt it or not. And then it does a map of everybody that feels it and how far away they are. Again, we collect a lot of data on these things. So I don't know. I think they're fascinating. But I don't know if they're flat Earth, globe Earth. I think that they're a fact of nature. And
so
I think
how would you triangulate this on the 2 cinder blocks being pushed together? You're holding it from the outside of the cinder block. Can you triangulate what the cause is? Like this is
what
the
you're
hand
doing
that was
on
moving?
Here. But they're not particularly like that. You're feeling the ground shake, and you have all different sensors picking up ground movement. And so they're going to, again, different locations at different areas and different strikes, try to zero in and do that. So sometimes, again, sometimes I'm moving together like that. It's usually catching it more or less a sticky wicket place, or that more, again, you're too smoothing, you're doing polished bricks or, that, but that's, in nature, I'm thinking there are much more jagged rocks that are catching, or there's a good possibility there can be. I mean, this is just one scenario on it. So I don't know. I feel like I'm shooting you down, but I don't mean to be shooting you down.
You're fine.
I'm just
you're
looking.
fine.
To me, it's fascinating. I'm fascinated with it. I just don't know, like when we talk about where we're going, because I've seen the arguments in the directions of it being and how it has to with the P waves and the S waves and the way that they measure it. But again, they came up with these measurements and everything, trying to reverse them into a model, or trying to, again, learn about the Earth from this and then take it back the other way and throw it back at you there. So it's like not a thing like that. The earthquakes, I don't know. I think you're doing like models. They're much more your EM model, flat Earth model, or flattish Earth in that model. I mean, they work perfectly within the realms you would need them in that and globe. Again, it's an interesting. Earthquakes are, again, a natural phenomena, and
yeah,
I don't see them as proof one way or the other.
Yeah. I can see how this would work on a flat Earth just fine. I can also kind of see it would work on the globe Earth by the same principles. But the only thing here is my whole pointing a finger at their claims here. They're wild claims about these S waves not being able to travel through the liquid except for the water table. So somehow they can travel through the water table but can't get through the
No, that is a good one. They can,
liquid core. And the whole claim to all these different layers of the Earth, right? Like there's so many times where they just make these big guesses, and then
they make the
treat them
big
like
guesses.
proof.
That's what I mean. They treat
Yeah.
it like a proof and turned it around on there. So again, they just turned it around because they decided that this was the way it worked with the P and the S waves, and then they didn't take in consideration the water table. So again, you just find these little things all the time that will cancel them out. And that's going to be inevitable because they are building their model around something false on there. So again, if your PNS model should work, if they work during liquids, they should work with the water table too, if that's what you're trying to say on this. That would be an excellent point.
I think that's for sure is water ends up being an originator for a lot of different movement. And so if one area starts to receive a lot more water, it can actually cause swelling of the ground. And so around here, a lot of people have to do extensive testing of their dirt for purple clay, and purple clay reacts really strongly with moisture because it'll swell and it'll end up cracking a lot of foundations. And so a lot of the surveyors will have to go and, you got purple dirt here too much. And so we're going to totally rip out all the dirt from your property and replace it. And they actually do that around here. It's a common thing. I just watched it down the road. It's like, why not? People are wondering why they have to do that. They're not even building a basement for this building, yet they're totally just changing out the dirt that the building is built upon just because of this purple dirt factor. Yeah. So this can cause we'll talk about more of I think we'll probably talk about that in earthquakes, where we're talking about, sinkholes. I was planning on talking about that later. We'll save that one for later. Talking about sinkholes, because it has to do with this. You get this big swelling of the dirt, and then all of a sudden it dries out, and then all of a sudden it wants to collapse. And so talk about that later. But yeah, those are my big three things on that one. Is if something were to swell up on one side of this and cause this entire block to move, it's going to grind all along that block. And I'm not going to say that one point on that entire block was the cause of it all. I'm going to point to the big swelling motion that happened on one side of this block that caused the entire thing to move. I don't know if you follow that or not, but I really appreciate you guys letting me know if I'm saying something that just really you don't agree with, because be yourselves. I appreciate the free thought.
Well, we're pretty much, that is like what I do too, is look at things and call. Again, it's not always easy to work with because you have somebody, well, really? Well, I don't think so. But no, I like learning and getting into the things. But yeah, I'm going to call out with questions on that. Otherwise,
Yeah. That's how we learn.
Mm-hmm.
Yeah. I feel like I've learned so much more after college, after I learned about it, because when I'm kind of sitting there on the spot, you've got the timeline or the deadline. You've got to cover all this material in a short amount of time. So you don't really have the opportunity to just sit and think about it for long periods of time. You don't want to get rushed through the material. You know what I mean? And so when you're at home and just kind of studying it on your own, you're able to pull out the magnifying glass and really think about it. And so I like the board here because I allow everyone to just come on here and share their thoughts. Some people can present some pretty good stuff. So that's what I got for you today. Anything coming up with you, Cammie?
Oh, that's good food for thought. Just trying to get myself going. We are working on putting a festival on here in October and trying to get the energy up. And so we do want everybody to come to our festival. It's time to lighten up a little bit. It's time to light some fires, dance a little bit on the music, enjoy yourself. I know everything has felt so heavy lately, so heavy, so dark, so dismal, and it's like we need to break the spell. Break the spell by casting the spell. I can't think of a better way. Actually, we are calling it esoterica, but it's not really all that witchy. It's talking about nature. It's talking about the creator. It's talking about the realm that we live on, and talking about, again, the deceptions that people are trying to program into us. And is that okay? Is that okay? So I think it's worth talking about. I think it's worth getting together. I think it's worth putting our heads together, doing some celebrating. Just that there's some other people paying attention out there with you, because sometimes there feels like it's not. Sometimes you feel like you're so alone in this world. And so I don't know. I'm ready. I'm ready for a festival. I'm ready for a festival.
Me too. I think
Can we
we all
be?
need that
Can it
energy.
be this week?
Yeah.
Can it be
Yeah.
now?
There's a certain energy that comes to it. And I think that's why you keep doing these things, right? There really is an
Definitely.
uplift that comes from that kind of stuff. Do you want to share screen and share the video on that? You got it. Karen?
Oh, she didn't know she had to be prepped. I don't
Sorry.
have that
I
one up
know.
on my channel. You didn't, and I didn't download it to my channel, and it's on my phone, and I don't know how to make it go from there. At one point I will learn tech. I should say that. I probably won't. We can't talk. There will be a festival here. We are having a festival here in Spartanburg, South Carolina. Beautiful Spartanburg, South Carolina, in October 17th, 18th, and 19th at the music camp, which is 55 acres of bliss. It is there's like little kitchens, there's little gazebos, there's little stations, trails, nooks, a beach, all kinds of magic. They have fireflies. I don't know if they will still have fireflies in October. That's asking a lot, though I have seen some out of the season. We're going to have people there. We're going to mostly have music and fun there and camaraderie there. And we are getting some of the last minute details together.
Yeah,
And we have
yeah.
some more people to add, and we're actually just getting things going right now.
But we do have people that are coming. We have lots of people lined up, lots of music, lots of we've got artists, we've got tarot readers, astrologers, stuff like that. It's part of the
And
fun.
things Mhm. And something I'd like to get into more, because not being witchy or anything like that, in a flat earth, we are told to look to the heavens for signs.
Yeah.
And they do everything to keep our eyes off of the heavens right now. Everything is meant to keep your eyes glued onto a phone and off of what's up there, what's out there. So I think any like a way of getting your eyes on the sky is magic and needs to be done. How are you doing on that download, Karen? Did you find the video?
Yeah, I have my screen share. Kyle, do you see it?
Karen,
Yeah.
I
yep,
see
there
it.
we go. Cool. That's
I
for me.
keep on hearing, where is the curve in my mind, by the way, with this?
Yeah, that's for me. I'm still working on the textbook that I've been writing. I have a metaphor that I refer to sometimes about a person can't complain about the only cake on a table, right? If you're complaining about the only cake on a table, you've it's kind of on you to present a better cake, put that on the table, and then say, this is the better cake. But even if it's a crappy cake, so long as it's the only cake on the table, it's the best one on the table. And so this is me trying to remedy that by writing a textbook and saying, okay, here's my cake. I'm going to go put that on the table. And yeah, now I have the right to complain about all these other textbooks. You know what I mean? So I'm currently working on chapter 2. I'm kind of moving along. I keep thinking of more things to add to it. So it's kind of fun
And that's
stuff.
wonderful. Wonderful and ambitious enough to go through and do all of that. I love it that you are.
Yeah, that's the fun thing about all of this is as I'm doing all of the studying on critiquing these other textbooks, I'm taking notes as I'm moving along so I can do a better job of explaining things than they did.
That should be pretty easy to do. That should be easy to do. It's funny looking back at the textbooks because I've not looked at textbooks in so many years because I'm older than dirt.
Oh,
And
here we are.
those, they didn't look like college textbooks to me. I've got to be honest. Though it's fun going back. It makes me feel smart, I guess. But yeah, I don't remember. I don't know. They just do not feel like college textbooks to me.
It's interesting
Like high
because
school.
yeah. Well, the first one we were reading was from high school, and then we hopped over to the college textbook and we're reading from that. So we're kind of reading from both of them, just so you know. Kind of hopping it back and forth from the high school to the college and stuff. I like the way the high school words things a little better. It's smoother off the tongue. Yeah. But yeah. So anything else you want to share, or just hop right into the video?
We can hop into the video and talking about it. It's a lot the same. That's again back to the basics of things. Just looking at the astrology and the tarot and that on the missing things right now. I'm looking back for different pieces. What am I missing? What I feel like there's something that we should be paying attention to and that we're not. And I'm just trying to find that missing piece. What is that
Absolutely.
missing
Yeah.
piece?
Also natural physics and stuff like that, cymatics, magnetism, electricity.
There's
Getting into
so much there
electricity, yes,
yet to be
so
explored.
much there.
And that, I think
And
that's
instead
what I
of
love
doing that,
about all of this.
And I want to get back to it. The magic, and that really is the magic, the electricity, the magnetics, the way that nature works. The natural physics is magic. There's no other way around it. There is no other way around it. And so if we're getting witchy and magical, we're going down to the natural physics. You can't tell me when you look at like an anisotropic where I'm making colors shift on the screen, or again, the fire tube that you see the music. You get to see the music. You can't tell me that's not magic.
Yeah.
And that's what I want is I want the magic back. So with that, Karen, let's intro the esoterica world. Liz the Iron Maiden, our lovely voice actress.
Solve the mystery. Esoterica, Music and Art Festival. Decode the mysteries of the occult. October 17th, 18th and 19th, 2025. Happening in Spartanburg, South Carolina at the Music Camp. Fire, water, air, earth, ether.
Featuring Austin Whitsitt of Whitsitt Gets It. Live music by Chief Crow. Mario Garza of Symbolic Studies. Artist Watson Atkinson. Live music by Alex Lowry and Christopher Crum of Don't Follow Crum. Plus more to be announced.
Decode the mysteries of the occult. Gain wisdom, shed fear. Esoterica. Go to esoterica.world for tickets and for more information.
Okay. Thank you. Really look forward to that, and can't wait to hear from about just how successful that is. Because yeah, right now is a good time for that kind of mass revival, getting that energy back. I think we all need
Yeah,
it.
and it's going to be in October. It's after hurricane season. It's when we usually have very mild, very pleasant weather here in the Carolinas. So there'll be camping, campfires. Dr. Law is going to be cooking food. If you're a camper, you can bring a grill and grill your own food.
Pretty
So,
much everything there. If it's not there, it's really, really close. It's easy to get to. It's comfortable and fun.
yeah, and if you don't want to camp, there's hotels like within 5 minutes, very close. So it's going to be awesome.
Okay. Thank you. I think that's a wrap.
That's a wrap.
All right. Peace.
All right. Good night.
Good night, everybody.